Hi guys, my name is Alexandra DeSico Camborian, and today I will be talking about whole interval recording. So the definition, a time sampling method for measuring behavior in which the observation period is divided into a series of brief time intervals, typically from 5 to 15 seconds. At the end of each interval, the observer records whether the target behavior occurred throughout the entire interval. Intends to underestimate the proportion of the observation period that many behaviors actually occur. So the target examples, the target behavior attending to tasks. Student Jack was instructed to complete his independent work. Jack sits at the table with feet on the floor, hands down, oriented towards his work presented with no interfering motor stereotypy, rocking, laughing, random comments. Target behavior, for example, number 2, is attending to tasks. Student Jack was instructed to be looking at the teacher while he is talking. Jack should be sitting at the table with feet on the floor, hands down, and oriented towards the teacher with no interfering motor stereotypy, rocking, laughing, random comments. So non-example would be student recording the duration of time Jack engaged in scripting the television show SpongeBob SquarePants. Another example would be staff recording the duration of time it took Jack to complete his written assignment. So the rationale, the student you work with engages in a behavior that is difficult to keep count of because it occurs at such a high rate. So lots of times recording this is challenging to do with just the teacher. Most of the time they'll ask a paraprofessional to come in to help record the data because the teacher's trying to give a lecture. It's really challenging to stop every couple of seconds to record a behavior or even to catch the behavior when it's occurring. I would not use whole interval recording for low frequency behavior. So for example, data collection. For data collection, I will be using a time and a data sheet. First video example, subject is Jack, behavior is attending to math assignment. Jack should be sitting at his table, feet on the floor, hands down, oriented towards his assignment with no interfering motor stereotypy, rocking, laughing, or random comments. Non-example, recording the duration it took Jack to complete his assignment. So when I was practicing my slideshow, I was trying to record the data and watch the video at the same time, but it won't let me do that. So I had to go ahead and already fill out the data collection. So we can watch the video and see if my data collection matches up to what you folks think. Students, it's time to do your math work.
SpongeBob.
So as you can tell, the first interval and the last interval, Jack engaged in target behavior. He attended to the math assignment throughout the entire 15 seconds. So I put pluses right there. I put minuses in the other 3 because Jack was rocking in his chair, laughing, or calling out random things like SpongeBob. So the student did not engage in the target behavior attending to the math assignment throughout the entire 15-second interval. So then the total, I put 2 over 5, and then that would be 40% of the goal was reached. So the ultimate goal would be 100%, but anywhere from 80 to 100 is what we tried to aim for. And then For the second example, data collection. For data collection, I will be using a timer and a data sheet. The second video example, subject is Jack. The behavior, student Jack was instructed to be looking at the teacher while he is giving a math lecture. Jack sitting at his table, feet on the floor, hands down, oriented towards the teacher with no interfering motor stereotyping, rocking, laughing, or random comments. Non-example is recording the number of times Jack yawned during the lecture. So again, I had to go ahead and record the data collection first. So we'll just watch the video and see if it matches up.
Priority, we do the 10 divided by 5 first, which equals 2. And then we subtract 2 from 20 and get 18 as our final answer. And here's another problem. 12 divided by 6 plus 5. Again, our rules say to do the division before addition. So 12 divided by 6 equals 2. And then we add 5 to get 7. And here's one last problem. 40 divided by 4 times 5. Which do we do first? The multiplication or division? Our rules don't tell us. Well, that's because multiplication and division are tied for priority or importance. So are addition and subtraction. And that's the reason we need an extra part at the end of each of these rules that says from left to right. If you have a problem that has both multiplication and division, then you're supposed to work it from left to right.
SpongeBob!
That's because in some cases you can get
Pudding!
to go from right to left. For example, in this problem, if you work from right to left the wrong way, you would do the 4 times 5 first and get 20. And then 40 divided by 20 equals 2. But if you go from left to right, you would do 40 divided by 4 first, which is 10. And then
Okay, so for this example, the first interval, the third interval, and the last interval, Jack was engaged in the target behavior. He was oriented towards the professor or the teacher, and he was listening, and his feet was on the floor. He was attending without shouting out comments. But the other two intervals, he was rocking and engaging in motor stereotypy by yelling out comments as well. So the total is 3/5, which is 60% of the goal reached. Here is the data sheet. And now it's your turn to collect data using this data sheet above. And here are my references. Thank you guys.